So since today we're going to be starting a new unit and we're going to be looking at systems of equations is what we're going to be looking at today, let's take a look at how they're actually used in the real world. This problem says the drama club is selling tickets to their upcoming production Grease. Student tickets cost $5 and adult tickets cost $10. If they sell a total of 45 tickets and take in $325, how many student and adult tickets were sold? Now, what do you notice right off the bat about this problem? How many unknowns do you have? You have two unknowns. You don't know how many student tickets you sold or how many adult tickets you sold. Do you think you might have a couple of possibilities? You might possibly have a couple possibilities. So when you see that you have two unknowns, what else do you notice in this problem? What did they give you up here? They give you the cost of a student ticket, adult ticket, and a total number of tickets and a total number of money you took in. So can you see that you're actually given two totals? Do you see that? When we have two totals, then you're looking at two different ways that we can solve this. Let's look first at a total of 45 tickets. If I have a total of 45 tickets, how do I get that total? If I know that X represents our student tickets and Y represents our adult tickets, X plus Y, that's it. Okay, then our other total is $325. Well, how do I get the dollar amount total? Okay, I'm going to say Y is the adult, so I could say 10Y plus 5X would give me then my totals. Now, can we get a lot of different numbers to add up to be 45? Sure we could. We could get 40 and 5. We could get 10 and 35. You would get all kinds of different combinations, can't we? But we also have to try to meet this criteria of earning $325. Do you agree with that? Okay, and there might be even more than one way that we could get that as well. Well, in order for this to be solved where it meets both criteria, this is what we call a system. And we're going to solve this system. In other words, we have to meet both. Now, the old-fashioned way that you all solve this, can you guess which problem-solving strategy you might have used? Guess and check can get kind of cumbersome, can't it? Okay, so let's just take a few minutes to think about some guesses that might work, and let's try to check them. I'll give you a few minutes to do that. Okay, so to set this up, we might try to organize our data. I kind of put my adult tickets together and my student tickets together, and then I know that I must total 45 tickets. Okay, so I must keep in mind that however many of each one, Y and X, must add up to be 45. So I started with, okay, 40 adult tickets. So 40 times 10 is 400. And how many would I have to get of the student then? 5. So 5 times 5 is 25. Uh-oh, I know that's not even close. That's way too much. It's $425, way over the $325 target that I'm trying to hit. So then I dropped down to 30. Let's say I had 30 adult tickets. So 30 times 10 was $300. Okay, draw a line. That was the first trial. And then how many of the student tickets would I need to buy if I bought 30 here? 15. Okay, so 15 times 5 equals 75, which gave me a total of $375. So that's too much. So then I dropped it down to 25, but I probably should have dropped it all the way to 20. So let's take 20 times 10, which is 200. And how many student tickets would I have to sell then? Because remember, we want those two totals to add up to be 45. 25 times 5 gives you 125, which gives you a total of $325. So did it work? Did we meet the criteria where I have a total of 45 tickets? So X is equal to 25 and Y is equal to 20. We're going to sell 25 student tickets and 20 adult tickets. So this is a long process on how to use guess and check in order to solve what we call a system when you're given two different totals. But this is just kind of an intro as to what is a system. We're going to, throughout this unit, find some shortcuts as how we solve systems of equations. Are you going to be ready for that? So you don't have to use guess and check all the time? Okay, we will do so. So what can we term as a system? What is a system of equations? Well, what is your digestive system made up of? Different parts, different parts. Okay, so in mathematics, we call a system of equations as just several equations. In this case, we're going to look at two or more equations. And they're linear. Two or more linear equations. Remember, and a linear means it makes a straight line. So in this unit, this is basically what we're going to do. This whole unit, we're going to look at three different ways to solve a system. The first way is by graphing. The second way is by what we call substitution. And then the third way is called linear combination, or sometimes you'll see it as elimination. Today we're going to look at just the first way, to graph the equations. When we graph two linear equations, where they cross or where they intersect, it's going to be an ordered pair, is going to be the solution. So in other words, if we're thinking back at the problem we just had, we could say that the ordered pair, our solution, was, how many student tickets did we need? Was it 25? So the ordered pair would have been 25, 20. That would have been our solution. And that's the method that we're going to look at for today. We'll get to substitution tomorrow, and then later on then we'll do the linear combination, or I call it the canceling out method or elimination method. Show me fist to 5. Are you ready to move on? Okay, I'll give you a few more minutes. For the first method today, we're going to look at solving a system by graphing. I want you to think back of the different ways that we have graphed linear functions or linear equations. The most popular one that we know is using the slope-intercept form, or y equals mx plus b. But if your function or equation is not written in that form where you have solved for y, there are some other options. But you have to be careful because they may not be the best options. If a linear function is written in standard form, you could use the cover-up method. That's one possibility. But if you start getting numbers that don't fit nicely on a grid, you want to avoid that. Because the only problem with graphing is you have to be very exact, and your lines have to be drawn very precise in order for you to get the right place where they intersect. Okay, you ready to try one? Let's graph these. Now, do you want to use cover-up method, or do you want to use y equals mx plus b? Okay, try cover-up for this one. All right, let's get your x-intercept. What's the x-intercept? Cover up the y. So divide both sides by 2, and you get 6. Okay, so that would be 6, 0 for one order pair. Now for the y-intercept, cover up x, and what do you get? So it would be 0, 4. All right, so let's plot those. 6, 0. And 0, 4. And then draw your line through them. And we label it as this is 2x plus 3y equals 12. Now, if you had chosen to use slope-intercept form, then you just need to get y by itself. I would have subtracted 2x, divide by 3, and I get y equals negative 2/3 x plus 4. So I know I would plot it at 0, 4, go down 2, over 3, down 2, over 3. Any questions on either way? Okay, so I have shown you both ways, the cover-up and y slope-intercept form. You can choose. Now, we only have one of our equations graphed. Let's do the other one. Which method do you want to use? Do you want to use cover-up again? Okay, so the x-intercept, cover up the y, and what do you have? 2. So it is 2, 0. Very good. For the y-intercept, cover up the x, and what do you get? -4. So it would be 0, -4. So let's plot those, 2, 0, and 0, -4. No, on the same grid, because we're going to find out where they intersect or where they cross. And that point will be the solution. And make sure you draw your lines, use your straight edges, the rulers that I've given you. If you've lost it, you can get a new one, please. And this equation is 2x minus y equals 4. And you do want to kind of label those so we know which one belongs with which. If I had solved for y, I would have had y is equal to 2x minus 4. Intercept would have been 0, -4, up 2 over 1, up 2 over 1, up 2 over 1. And where is it that they intersect or cross? Okay, it's a nice point. It is a grid mark, an intersection, and it would be 3, 2. So 3, 2 is your solution. That is your solution. Now, what does that mean to you? What does 3, 2 mean? I could plug in a 3 for my x in both equations and a 2 for my y. It'll make them both true. Okay, so let's try it. You 4 over there, try plugging them into the first one. Okay, you 3 and we will plug them into this one. Go. Are you done? Okay, what do we get here? 3 times 2 is 6 minus 2. Does that equal 4? Okay, so that one checked out. What did you guys get over here? 6 plus 6, does that equal 12? Sure does. Okay, it checked out. So that's how come it is true. That is the solution to this system of equations. Questions? Okay, let me have you try this one on your own, and then we'll check it. Your two equations are 2x plus y equals -4, and then you have y plus 2x equals 3. Okay, now we can solve it either both ways, either doing the cover-up method or slope-intercept form. I come partial to slope-intercept form. Y equals -2x minus 4. But if you did the intercept or the cover-up method to find the intercepts, the x-intercept, cover up the y, and you get what? -2, 0. And the y-intercept, cover up the x, and you get 0, -4. Okay, so we can go ahead and graph this one. My y-intercept is 0, -4. And I'm going to go down 2 over 1. Or I can plot a -2, 0. Up 2 over 1, up 2 over 1. And then we draw our line. And label. And this one is 2x plus y equals -4. Now, if you wanted to label it when you solved it in slope-intercept form, you could label it that way also. That's fine. Okay, for the second one, if I solve for y, I get y equals -2x plus 3. Or if I have the intercepts, because it is in standard form, the x-intercept, cover up the y, and what do you get? 3/2, 0. Okay, to get the y-intercept, cover up the x, and you get 0, 3. So this one isn't quite as nice to use the intercepts. Do you see that? So that's why I would prefer actually to do it in the slope-intercept form. Your y-intercept is 0, 3, and I'm going to go down 2 over 1, down 2 over 1, down 2, over 1. And this one is y plus 2x equals 3. All right, what do you notice about these lines? Okay, the two lines are parallel, so what's supposed to be our solution? Where do they intersect? Do they? Will they ever? No, because they are parallel. Now, you know, how do you know for sure that they're parallel? What do you remember? The slopes are exactly the same. Good. The slopes are the same. It means that they are parallel lines. Therefore, there is no solution. No solution. They will never cross. So in other words, there are no numbers that you can put in there that would make both of those true at the same time. Okay, let's take a look at one last problem. I'm going to solve for y so that I get y equals negative x plus 3. I believe that's right. Subtract 2x, divide by 2. Thumbs up if you agree with that. Okay, and then the second one, y equals, I subtract 5x divided by 5, x plus 3. Which should be a negative. It'd be a negative? Yes, because you're going to subtract 5x's from both sides and then divide by 5, so I get negative x plus 3. Now, what do you notice about these two equations? They're exactly the same. Well, they don't look the same here, but they are exactly the same. Therefore, we are going to graph them, and it'll only be what? What do you notice, Gavin? There'll only be one line. Therefore, when this happens, what do you think we're going to say about our solutions? There are many solutions. There are many solutions. Any of these numbers or ordered pairs on this line would then make it true. So we have many solutions. And those solutions are any ordered pair that would fit on that line. It's just not any real number, but any real number that would fit on this line. Questions on that one? That was a little different. Okay, let's solve for y. Subtract 3x, and you get 2y equals negative 3x plus 4. Divide by 2, I get y equals negative 3 halves x plus 2. That's not very nice, is it? But we might have to deal with it. We can work with it. Okay, so as we graph it, I get 0, 2. Down 3 over 2. Down 3 over 2. Make sure that your slope looks like it's going in a negative direction, is it? Or you could go up 3 to the left 2. Make sure just one of your moves is a negative move. And we label this one as y equals negative 3 halves x plus 2, or you can label it 3x plus 2y equals 4. Okay, then we're going to do the other one. I'm going to add 3x to both sides. And I get 3y is equal to 3x plus 5. Divide everything by 3. Y equals x plus 5 thirds. Ooh, how do I do this one? Okay, well, your y-intercept is going to be 1 2/3, so about right here. And I'm going to go up 1, so up 2/3 over 1. Up to the 2/3 and over 1. You actually have done this before. We have done everything you need to know today. It's just that we're putting two systems or two equations now on the same grid because then we're finding the solution where they cross. Now, what do you notice about this? Is it really nice to find where they're crossing? Okay, Crystal's saying no. So this is the only negative part to graphing. Okay, so that's why we're going to find tomorrow some other solutions as to how do you find the solution to this linear system. We're going to find a different way. Okay, so we'll pick this one up tomorrow. But today what you're going to have, you're going to be able to solve, you will find an ordered pair that satisfies both, and it will come out nicely.